Hello, my dear student. I am B S Pandey, your physics lecturer. My dear students, in series of standard 11 physics, today we will start new chapter. It is friction. Actually, this is the part of a chapter in NCERT. It is the laws of motion, in which you have to study about the friction. Okay, but when you will turn the S.C. Burma book, you will find a chapter especially designed for the friction. Okay, my dear student. So let us start today's lecture. It is lecture number 33, and we'll study about the friction in this chapter. Right? It is friction. Lecture number 33. My dear students, when we talk about the friction, it is not that topic that we have not studied from our childhood. We know very well about the friction. Okay, more or less we are having the concept of friction. We know that from our childhood. From standard 8 we haven't studied. When in standard 7th or 6th it might be introduced about the frictional force. In very general term, in very general language, if anyone don't know about the friction very well, then he or she can say that the friction force, it is a kind of force which opposes or try to oppose the motion. Okay, the motion of body. But my dear students, in fact, it is not necessary that the friction will work if any body is moving, and that friction force try to oppose the relative motion of the body over any surface. In fact, this friction force act on any body to stop that body. It just try to stop that motion body, or it is the force which try to oppose the tendency of motion. If any body want to move, then it start acting on the surface, on the body surface. All right, my dear students, we will discuss in very detail about the friction force and what are the nature of friction force, the laws of friction force. But here we are going to start with the concept of from where this friction force comes into the action. My dear students, if I'll draw a body like this one, so it is quite obvious that the surface is rough, my dear students. Then you will say, from the experience of your childhood, if any force is acting in this direction, it is the external force. Then you will say, of course, there will be the friction force. It will act in this direction to oppose the motion that is against the external force. My dear students, if you do the free body diagram, then it would be very easy to see where this friction force actually acts. My dear students, I've just kept this body above the surface. Then you can say, yes, the friction force it is acting. Since the external force it is acting at here, then friction force will act somewhere here. All right, from the surface, and the friction force will act in this way, opposite to the external force, and it will try to stop this body or try to oppose the external force, that is the relative motion between these two surfaces, that is the ground and the body. My dear students, now from this very simple introduction of the friction, we can say that friction is nothing but the form of force. Remember, it is the form of force. All right, and how we will define it? So this is kind of force which acts opposite to the relative motion of the body. Remember, it acts opposite to the relative motion of the body, or it acts to oppose the tendency of the motion of the body. All right, so this is the force that we can give the definition. You can write that definition what I told right you. My dear students, the next point, it is the friction force. If you rub your hand like this one, then the friction force actually creating some heat energy. Am I right? Yes, it creates some heat energy, and you know that the heat energy that created by the work done. I'm rubbing my hand, that I'm doing some work over by one hand over the another hand, and this work done, it is creating the amount of heat energy. Yes, we can feel the one, that is we can feel heat energy, and that heat energy actually lost. All right, it lost. So you cannot retrieve that heat energy which was created by the friction. Actually, that friction is doing some work which created the heat energy, and that heat energy lost. All right, and we have studied already, I will teach you in work by energy chapter, that the amount of work done due to which, okay, the force with which the force, actually the work done, it is lost in any form, that is basically the heat energy, or you can say in any form. If any amount of energy lost by the force, that force is known as a non-conservative. You cannot conserve that, you cannot study that force is conservative in nature. Why? If you are studying that in work by energy, you will study in a round trip. If the work done is 0, might be you have studied in standard 9th also, in round trip if the work done is 0 because the displacement is 0. But in this case, in friction or in such a forces, if the force is acting and the body taking round trip, but the net work done is not 0, then that force will be considered a non-conservative force. Here this friction is the same kind of force by which the total work done in a round trip never be equals to 0. It means it is a non-conservative force. But we will discuss later on in very detail about this topic also. At this point also, it is non-conservative in nature. Finally, remember, my dear students, it is non-conservative in nature. All right, what does it mean? That is, work done by this frictional force never equals to 0 in complete loop. Okay, in a round trip, if the work done is not 0 by any force, then that force will be considered a non-conservative. All right, that is, the work done by non-conservative force never be equals to 0 in a round trip. That is the complete loop. All right, now it is very important to study in which direction actually the force act. So we have studied it act opposite to the relative motion. If the relative motion of the body is in this direction, this is the direction of relative motion, then friction will act in this direction. You can see here I am representing the frictional force. All right, this is the very important. So you can write here the direction of frictional force must be opposite to the, you can say, relative motion. Of the body. All right, my dear students, it acts opposite to the relative motion of the body. This is the condition. Now, why this force actually comes into action? So, my dear students, the frictional force actually acts due to the asperities. It is present in the surface of body. We know that all the surfaces are not perfectly smooth, and that roughness create some asperities. All right, that is the irregularities. So this irregularities, that is the asperities, look at here, over the surface of the body it is moving. This is the surface. All right, but over the microscopic scale, if you will see the surface, it looks like this one, the zigzag. All right, if you place a body, look at here, it's okay, it's looking very smooth, but in fact microscopically you will find the zigzag pattern. And if you apply external force, what will happen, my dear students? This asperities, that is the irregularities, get interlocking with the surface. It interlocks. All right, this asperities will interlock while moving, and it interlock in each other. To just overcome this interlocking, we apply a force, and due to this interlocking, you will say the obstacle obstacle experienced by the moving body, and that is nothing but the friction. So this is the root cause of the friction. Okay, my dear students. Now we'll get to the types of friction. What will be the types of friction? If any body is in a static state, suppose external force is acting, but this body is not moving. For example, look at here, my dear student. This is my duster. I put this duster on my hand. I'm applying a force over here. You can see. Look at here carefully, my dear students. I'm applying the force. Believe me, I'm applying the force, but this duster is not moving. Whether the friction is not working? Yes, the friction is working. Actually, that friction is working. If I applied here the 1 Newton, and if this duster is not moving, it means there's a friction of 1 Newton. It is acting. You cannot say that friction force is more than 1 Newton, my dear students. I'm applying here 1 Newton. So opposing force is equal to the 1 Newton actually. Alright. If the opposing force will be greater than 1 Newton, what will happen? This duster will move opposite to the applied force. But here I'm applying 1 Newton and it is not moving. It means the friction force, it is opposite to my applied force and it is equal to the 1 Newton. What will happen? Whether is it necessary that if I increase the force by 2 Newton, this duster will start moving? No, it is not necessary. If I apply force in increase by the 2 Newton, now it is 2 Newton. You can say again it is not moving. Remember, you cannot say that yes, the force you have not changed. Actually, I have changed the force. Okay, now it is 2 Newton, but it is not moving. What does it mean? It means now the frictional force is being increased. All right, but this duster is in a static state. Okay, it is in a static state. All right. If I increase again the force by the 3 Newton, 5 Newton, okay, 6 Newton, and after that force, instead, this body is not moving, it means you can say some force is acting opposite to applied force and that is also increasing. What does it mean? It means, my dear students, the force that is opposing or opposite to the external force is a self-adjusting force. That force is adjusting. Of course, if this can apply the opposite force, that is the frictional force, 5 Newton, and this body can apply 2 Newton also, it means the body is not applying more than the external force. It means it is a self-adjusting force. And that self-adjusting force, my dear students, is termed as a special name. It is called the static frictional force. Remember, it is the static frictional force. Once I exceed the external force, remember, this body has some limits, how much it can oppose the external force to stop this body. It has some limit. Alright, suppose I have just applied here the force by the 10 Newton and this body is in a static state. But at 10.1 Newton, it just starts moving. With 10.1 Newton, it starts moving. Then we can say the frictional force of this body, the maximum frictional force of this body, that was the limit. Alright, that limit, it can apply up to 10 Newton, not more than that. Yes, it can apply less than the 10 Newton, but it cannot apply the frictional force more than 10 Newton. And that value, that is the maximum value of a static frictional force, that is known as the limiting. That is the limit of this body. It can apply the maximum. Alright, that is the limiting frictional force. Now, if I applied here the 50 Newton, alright, 15 Newton external force, what will happen? This body will move over the palm. If it is moving, then the friction force it is acting, and that friction force, of course, is known as another type of friction force, and that is called the kinetic friction force. Remember, the dynamic or kinetic frictional force. Now, it doesn't matter if the body is moving with the 5 meter per second or 10 meter per second or 2 meter per second, the frictional force is not going to be changed. That will be the constant, and that force is termed as that frictional force. All right, that opposing. Okay, and after opposing that friction force, the body is moving. That friction force is called kinetic frictional force. So here we have introduced 3 types of frictional force, my dear students. One by one, we can write all these 3 force, and then we will introduce you the laws. All right, here the types of frictional force we can write. One, it is static frictional. Second, limiting friction. Third, it is kinetic friction. Alright, yes, one by one we will study those three forces. My dear student, here about the static friction that we have studied, and for the quite obvious, this static friction force, if it is represented by the Fs, it is Fl and it is Fk. It is quite obvious the static friction force, the static frictional force, it is able to stop the body. Am I right? Yes, it is able to stop the body. But this limiting friction force, remember, the limiting friction force is the maximum value of this static friction force. Remember, if you are increasing this applied force by 1 Newton, 2 Newton, 3 Newton, and the body is not moving, that is the self-adjustable, this static friction force, the static friction force, must remember, is self-adjustable. Remember, self-adjustable force. Alright, my dear students, it is self-adjustable force. It means the maximum value of this static friction is static, the maximum will lead to which force? Limiting friction. Remember, it leads to the limiting friction. And it means for any value of this static friction force, remember, it is not constant, it varies. Alright, it might be the 1 Newton, might be the 2 Newton, might be the 3 Newton, because it is self-adjustable, so it can vary. Alright, so my dear students, we can say this static friction is less than limiting friction. Am I right? Yes, we can write the static friction is less than limiting friction. Why? Because the maximum value of this static becomes the limiting. It means the limiting is the greater force. Alright. Now, if the body is moving, it means it has been lost the condition of limiting friction and it reached to the kinetic friction. Alright. And the kinetic friction, it is the kinetic, if the body is moving, of course, it is not applying so much friction force opposite to the motion. It is not applying so much opposite friction. It means this one is the lesser force than the limiting or the static. You can say the limiting friction. This one is the maximum force that you get. That is the maximum force in terms of the frictional force. Okay, my dear students. Now, we will try to understand the laws of friction. So, these are the kind of forces. Kindly give the heading laws of frictional force. When we talk about the laws of frictional force, my dear students, we often try to discuss the limiting friction force or the kinetic friction force. Remember, if any body it is kept in this way, suppose I have been kept this duster over my palm, and now if I'm asking how much friction force is acting, so the answer will be no friction force is acting. If no external force, if this duster is put over the palm, even elephant put over the palm, alright, there will be no friction force considered. You cannot consider the friction force. You cannot say the static friction force is acting. If I'll ask how much, then you will fail to find the value. Without applying the external force, you cannot say. If applying the 1 Newton, then you can say yes, static friction force 1 Newton is acting. It might be the friction force, that is static friction force will increase, but after applying the external force. Alright, my dear students? Yes. So here, the friction force, it is considered only due to the applied external force. No external force, no friction force can be considered. That is the very important. Alright, my dear students? Yes. Now, laws of friction force. Laws, kindly give the heading, my dear students. Laws of friction force. So, suppose, my dear students, we are going to study laws of friction force. So one point which is very important to study the law of laws of friction force. One, it is if any body is kept, we apply external force. Alright, there must be a friction force opposite to the relative motion. Of course, if external force is acting in this direction, there will be no relative motion in any other direction. There will be the relative motion along the surface. And a friction force, it is acting opposite to the relative motion. That friction force, we are going to study about this friction force, and we are going to give the law for this particular friction force. According to the first law of friction force, if you will draw the free body diagram, the mass is m, then you will find mg downward and there will be a normal reaction. Alright, if you are applying 2 Newton force, remember, if you are applying 2 Newton force, from here the 2 Newton force, it is pulling the body, then the friction force will be something. But if you will put mass, if you will increase the mass by 2m, apply the same force, my dear students, remember, apply the same force, there is no static friction force going to be changed. Remember, there's no static friction force is going to be changed. That is the self-resistive force not going to be changed. If this body is moving, my dear students, remember, if this body is moving, then this mass, that is the normal reaction, will countable. Remember, actually, this is a misconception. Remember the misconception. If this body is in a static state, the friction force it is acting, it depends upon the several quantities, the several things. It is a misconception. What is that? If I put this duster in this way, my dear students, in this way, so I need less force or more force. If I'll put this duster in this way, whether the friction force will increase or decrease. If the surface is identical, so in which case the friction force will be larger, in this case or in this case. This is a misconception. Actually, if we are studying the kinetic friction force or the limited friction force, in both the cases there will be no change in friction force. If we consider the self-adjusting force, might be it changes by the several amount, but remember, rather that force is acting, there is no motion of the body, which is very important. So remember, my dear students, this one. Okay, here the first law, that frictional force, we are talking about the limited force or the kinetic friction force. The frictional force must be directly proportional to the normal reaction. This normal reaction, friction force directly proportional to the normal reaction. Alright, if we will equate compensating constant, and it is called mu times n. Remember, this is called mu, and this mu is nothing but the coefficient of friction. Coefficient of friction. If we are talking about the static friction force, this will be the coefficient of static friction. If we are talking about the kinetic friction, and if we are talking about the limiting friction, then this will be the coefficient of such friction. That is the kinetic friction, limiting friction, or the static friction. So this will be the one very important formula for the friction. To study, to count, to measure the friction force, we require two things. One, it is mu, and the second, it is n. And this mu actually depends, upon the roughness. Alright, roughness of two contact bodies. Roughness of two contact bodies. Remember, this is not the value of any one surface. It is the relative value. It is the relative value. Alright, like this one. If I put this duster applying the 1 Newton, it is not moving. Might be if I'll put this duster over a glass or over a surface which is very smooth, by applying 1 Newton force, it might move. Remember, the surface is not going to be changed, but relative surface is going to be changed. Relative surface has been changed. That's why it starts moving. Alright, it again applying the same force, but it is moving. It means this mu is the value of relative contact bodies. Okay, it depends upon the two bodies. That is the nature, depends upon the roughness of two contact bodies. That is the nature of two contact bodies in with which the bodies are in contact. Remember. The second thing, which is very important, my dear students, let me rub this one. Okay, so what is the very important formula here? Fr, it is mu times n. Mu is the coefficient of friction. We will study the value of mu will be the very less, and it is 0 that we have studied here till here in laws of motion chapter. Mu was 0 for the very smooth surface. The mu is 0, which is impractical value. Remember, it is ideal value. It is not possible to have mu 0, but we study in numerical question. The minimum value of mu, it will be 0. All right. Now, the second thing, I'm going to rub my dear students. Can you know the second thing, which is very important, if this body is kept and applied by external force. All right. In second case, if this body is kept vertically applying the same external force and the surface are identical, remember, ideally the kinetic and limiting friction force we will study. Here the frictional force 1 and here the frictional force, it is 2. In both the cases, frictional force will be same. Remember. Why? Just we talk, it depends upon the normal, and normal is not going to be changed. Why? Because it will depend upon the component of the force, contact force, which is perpendicular to the surface. Remember, this is not the normal equals to mg always, but it is the perpendicular force over the surface on which this body is kept, which is very important. Okay, my dear students. So this Fr1 will be equals to Fr2. This is the second you can mention in law. Now the third one. Let me have this one. Friction force is composite. All right. It is the conjugate. Sorry. It is the conjugate force. It must act in pair. Remember. Look at here. If this is the body of mass m, external force, it is acting in this direction. Alright, kindly make the free body diagram of this mass. The force, it is external acting. The friction force, if you will see, in which direction this body is moving? In this direction, this is the motion. But if any observer sit over this body and try to see the motion of this surface, in which direction the motion it will looks like. So the surface moves in this direction relatively. This will be the direction of motion. Okay. If this friction force is the conjugate force, it must act in pair so that the net friction force must be 0 if there is no external force applied. All right. So if this body is moving in this direction, relative motion in this direction, friction force act in this direction, and over this surface, if this surface it is moving in this direction, all right, relative motion, then the friction force will act in this direction. Remember, my dear students, this will be the direction of friction force. Now you can think, if this body is kept over the another body, all right, if any body is kept over the another body, suppose, this is not very difficult to consider, my dear student, if these are the two bodies. Okay, here the smooth surface friction is 0, but there is some friction. All right, over this surface there is some friction, and we apply here the external force. All right, of course we know that over this body the friction force will be in this direction, but if this is the very smooth surface, then what you can visualize, what you can guess, that you can guess this body M1 and M2, if it is M1 and it is M2, then you can guess, my dear students, this M2 will move it will move along with the M1. we are not applying the external force actually over the M2, then which is responsible to carry this M2 in forward direction? Of course, here on this body the friction force is acting in this direction, but we have studied right now that it is the conjugate force. So over this body there will be the friction force in this direction, and this friction force is responsible to carry the lower block in forward direction. It might happen, my dear students. Try to think, if you have kept this body and another this body, look at here, another this body, all right, if I'm applying the force over here, okay, it might be the force is such that both the duster and this body, if it is the body made of iron, all right, if I'm pushing this body, it might be both the body is moving along it, moving simultaneously, and that means if here the friction is very less, all right, here the friction is very less, and for this surface the friction is not very much less, then I'm applying the force in this direction, and this direction producing a friction force. Over here the surface, it is in backward direction, but it is applying a friction force over here in this direction, and that force is responsible to carry this duster in forward direction. I hope you are very clear about this point. This particular concept will be used to solve the questions of SC Burma. Okay, my dear students. Now, as I told you, my dear students, the normal force, if you are acting, my dear students, if you are thinking, sir, if friction force is mu times n, then can we write, if this is the mg, because this is the n, then can we write this Fr equals to mu mg everywhere? Is it applicable? Then I will tell you, no, it is not necessary. How? So look at here, one case. We have discussed today, my dear students, the concepts of friction force, from where this friction force we can consider. All right. In next lecture, my dear students, we will start some numerical question. We start solving some numerical question. My dear students, look at here. If the surface is in this way, if this is the theta, a body is kept over this wedge of mass m. All right. Now, mg, it is in downward direction, this one. So could you write the friction force if this is the rough surface? All right. This is the rough surface, and if it is the friction, you have left this body, and if it is sliding down, then could you write this friction force, my dear students, as mu times mg? No, this is incorrect. As I told you, this is the normal reaction, so you don't have to remember this formula. Actually, you have to make and you have to find the normal reaction. You know that if this is the theta, this will be the theta, and this is the mg cos theta. So in this case, this is the friction force, then it will be the mu times mg cos theta. All right. So it might be the friction force, the normal reaction, anything, and due to which this friction force will be changed. Okay, my dear students. So, my dear students, today we have studied the basic concepts of friction. We have studied the definition of friction force, the types of friction force, and on which quantity this friction force actually depends. From next day, my dear students, we will start the calculative portion of the friction force, and we will study if any body it is kept over the wedge, how much time it takes, and what should be the acceleration. Do you remember, my dear students, the acceleration without friction? If any body is kept over the wedge, that is inclined plane, what is the friction? It is g sine theta. Here we will study what should be the acceleration if any body is kept over the inclined plane. And the second thing, my dear students, we will study about the angle of friction and angle of repose, which is very important for the school examination also. Okay, my dear students. So this is all about today's lecture, my dear students. Thank you very much.